Andrew is a systems engineer at Illumina. He has over 15 years of experience in security and quality assurance, working with organizations across Asia Pacific to strengthen their cyber resilience. Having worked with major industry players like Micro Focus and HPE, Andrew now represents Illumina South Pacific as he marries his knowledge of technology and industry to deepen and implement solutions that prevent attackers' lateral movement throughout the organization. Can you please join me in welcoming Andrew?
Thank you very much, Chris, and thanks everybody for joining the talk this afternoon. I really appreciate it. I think that as we get into this topic, and hopefully actually zero trust is becoming a bit more of a buzzword. So you've either kind of latched onto that and you kind of know what I'm going to talk about, or maybe just that enticement of marginalizing the breach will get you through this particular talk. And I think before we kind of get cracking on to what I actually mean around that, I think one of the key things that we've found in the security world is we've been very focused over a number of years around preventing attackers from getting into an organization, or trying to be much better at identifying when they're in with analytics and heuristics and machine learning, and trying to kind of react to that problem of what do we do once they're inside. It's been my pleasure, and I was very lucky to join Illumio recently here in Australia about 18 months ago, and they're kind of looking at the problem from a slightly different angle of not of assuming that breach is going to occur, but actually taking proactive measures to limit the blast radius or the exposure of that breach. And that's kind of where the beginnings of zero trust comes into life as well, is the assume breach mentality and plan beyond the breach. And you might be wondering, well, why would I be interested in this, or why would it be required to think about it in this particular way? And what I've got kind of up here on the slide, and hopefully the guys at the back can see this, I've got a few that might get a little bit smaller, so I'll try my best to talk them through. But industry, regulation, kind of compliance, and internal drivers are all starting to come along with this journey with our InfoSec professionals around a need to be able to kind of be more proactive in terms of identifying what some call crown jewel applications, or at least systems or software that manages data that is sensitive and is particularly important not only to the business but the consumers or the trust that you're building with your particular customer base. And whether that be a particular industry like financials, APRA, PCI, SWIFT, and other regulations have been around for a little while, whether it be government, and I come from Sydney, so kind of a New South Wales government initiatives are starting to take place of not only identifying those systems, but then having controls that are commensurate with the risk that they pose, and being able to kind of prove that we're doing the right things and approaching this problem in the right way. And whether that be, financial information, health information, personal information. I mean, we don't need to talk about what constitutes sensitive data in this particular audience, but we generally all have software or applications. We have IT departments, data centers, public cloud that is operating on this type of information. And the idea is that hopefully we can take a little bit more of a proactive approach to protecting some of that. So that's a little bit about what we're going to talk about today, and introduce that kind of concept of zero trust into the mix there, and how that kind of plays in. The other kind of intro that I would kind of mention around this, and comes back a little bit to the way that Illumio looks at the world and how customers of Illumio are kind of approaching this problem, is that if we have kind of an understanding about our existing known risk, and at least an appreciation of what a risk might contain, or what that might mean as an impact to the business, there's kind of two factors to that risk, and one is the exploitability factor, or how easy would it be for someone to actually achieve a breach of that mechanism. On the other factor is really kind of the likelihood of it happening. And we look at classic kind of risk graphs. That's what kind of you're plotting on an X and Y axis. And from our perspective, and the customers that we have, they kind of look at that likelihood or that reachability as one of the factors that you can actually have a lot more influence over, or even control to a much greater degree. The ability for someone to come up with a hack that will breach you in a way is a little bit less out of your control, but certainly the ability to limit the possibility of someone reaching a system that they shouldn't be able to access is something that we can control. And if we look at the hacking playfield, one of the things that we have as an advantage is that we should know our environment and be able to control our environment better than someone that's looking from the outside is attempting to break in. Okay? So think of it that way. Likelihood or the reachability factor is something in our control, and that's what we're going to talk about as we go through this and think about that zero trust method. And it kind of harps back, I mean, whether it's an attack or a MITRE or kind of an adversary life cycle, attack life cycle I've got up here, one of the key elements, and I'm going to kind of avoid all the bit at the front, which is the interesting stuff about how they're actually going to achieve breaching an organization. But our particular focus is generally around how do they actually manage to reach the systems that hold that sensitive data. And the typical breach patterns you all read about, hopefully you're not participating in, they all reflect that a low value, low risk system, maybe even one external to your business, is the point of compromise. But from there, they have the ability to either live long in that kind of persistent threat model, but certainly have an opportunity to then move within that environment to get from that low risk system, that easy to compromise system, into those systems that hold that sensitive data. So that lateral movement, that opportunity for walking through a data center, now that they have breached, is something that occurs pretty much in most breach notifications that you'll read in the news. And again, it comes back to that fact that we're concentrating on trying to plug all the holes and keep everybody out. We tend not to have a lot of control once someone manages to breach that perimeter. Okay? And zero trust is very much that concept of rethinking that, kind of turning that on its head, and trying to identify and prevent that lateral movement from happening in the first place. So this is, yeah, it's going on. So underpinning a lot of this talk that I'm going to do today is this concept of micro-segmentation or segmentation that you'll see come through this talk. And just to kind of give you an idea, hope that went past quite quickly, but blink if you missed it. But fundamentally, if we think an analogy around what segmentation means, it's nothing kind of new in terms of our psyche. If we built a submarine that was on the first page there, on the left-hand side, that kind of represented that open system, open hull, any sort of ship, any sort of breach, any tiny pinprick of water is eventually going to bring down the whole system. That kind of mentality of having a really high-pressured hull or a strong perimeter defense doesn't mean anything once it's breached, because down it goes. Whereas on the right-hand side, which is actually the way they build submarines, don't worry for anyone that is a submariner or wants to join the Navy, they actually build submarines in this way with lots and lots of bulkheads or compartments or segments, which fundamentally means they're expecting a breach to occur, right? So they're assuming breach, they're planning ahead of breach, but making sure that when that little breach occurs, and no matter how big it is, that it's compartmentalized, restricted or segmented, so that it doesn't bring the whole thing down. You can't get everywhere within the sub just because you managed to breach that hole. Okay, so that's the concept of micro-segmentation. It's kind of behind the perimeter, behind the gateway. How can we ensure that someone can't move or get access to everything once they're inside by building these little micro perimeters or compartments? Okay, and that's the end of my naval analogies. I've got a couple of road-based ones coming up soon. So the key thing there, yeah, it's probably inevitable that we're going to be breached, but we don't have to go down with the ship if that is the case. So bringing that kind of analogy back from naval back to kind of IT and departments, I mean, this is probably not a great diagram that describes all of your environments, but it's reasonably traditional in the sense that we've placed those controls around perimeters. We're probably building some level of kind of zoning within our data center, you know, the old classic DMZs and trusted zones, and probably using kind of traditional firewalling mechanisms and switching technology to kind of group systems together that might reflect maybe their classification of data. And this was kind of appropriate in the 90s, and then we kind of virtualized stuff. So for those that can see, we kind of chuck in a virtualization platform into a lot of that data center environment, and it kind of spans all of that. And then more lately, perhaps, moving out to a hybrid model around the cloud, multi-cloud coming into the play of that. What tends to happen is that if you manage to breach one of those zones, you've probably got free reign within that zone. It's probably not that hard to then swap or traverse zones, because typically we start opening up a whole bunch of holes between things of exceptions, and just to make things work, we've got to get things working for the app teams and the DevOps teams who have to run faster and faster. So we probably tend to start to see a bit more of a porous environment where the firewalls aren't really doing what we think they were doing. And then we have to worry about what we do in the cloud and how that works, and do we have kind of a different security posture completely in a public cloud environment than we would have had on premise, and a desire in a lot of cases to go to the cloud first strategies and so forth, and how we're going to maintain that. So typically this model doesn't really achieve what we're looking for if we're looking to isolate systems and protect that data. And this is obviously what happens in the breaches today. Most are operating in some form of model that looks a little bit like this. And the idea, and I apologize because you won't be able to see this at the back for sure, but the idea would be to build those compartments within each of those zones, or maybe even kind of phase away that idea of these big trusted zones and adopt more of an approach, which is the zero trust model of don't trust anything by default just because you happen to be in a particular part of the data center. All right, so each application or potentially each group of systems, or maybe even every VM that you run, should be able to have some concept of what am I allowed to talk to, and I should only talk to others in that way. And just because I happen to be in a VLAN does not mean I should be able to contact everything on that VLAN. Okay, so building segments is that way of reducing the attack surface, because it means that if an attacker does manage to breach some part, they can't get out of that compartment that they're in. The submarine still holds, and they can't get themselves throughout the rest of it. But the challenge is, how do we go about achieving kind of bringing these perimeters closer and closer to each application, or closer and closer to every compute point that we have? And particularly when we start thinking about cloud, where we don't own the infrastructure, we don't own the network, how can we achieve kind of this network-centric security model of segmentation if we don't actually own the network or be able to interact well with the network at all? So this poses a real challenge to us. So yeah, zero trust. Just actually by a show of hands, has everybody heard of the term zero trust? I call everybody. So everybody knows what the definition kind of is, right? You don't implicitly trust anything around you or develop a policy that would mean that you are implicitly allowed to do something. Objects in the network should be no more trustworthy than anything outside the network, and the idea is to kind of bring down these micro perimeters. And Forrester is obviously an analyst group that's been pretty heavy on this. Chase Cunningham, if you're not already familiar, has done a lot of work in this area in terms of describing a zero trust framework, which looks to identify how we can protect data and systems and people in a fashion that is orchestratable or automated, okay, to keep up with the business that we're running. But fundamentally, they realize, or they reckon from their particular research, that you can reduce a lot of your exposure and risk, which is obviously a key goal of any security type program. But you can also reduce the cost associated with running what you're doing today and achieving an even better goal than you have in terms of the granularity of control that you can have over these systems. So that's a cool thing. It's for those that, most of people said they kind of realize zero trust. Just as a second show of hands, is anybody kind of running an entire zero trust framework already, or on the journey towards, or think significantly enough on the journey towards? A couple of hands. So there's probably a lot of opportunity perhaps to really key into that and see how that would kind of work for your organization. All right, so I'm going to kind of bring this zero trust model back into that concept of building segments and compartments, because ultimately that kind of really fits the bill of zero trust. No implicit allows, deny by default, lock everything down into small micro perimeters. We can achieve that, hopefully we can achieve that across our modern data centers today. So how would we have done that, or how could we approach this problem? If we were looking to try and reduce connectivity between all these systems only down to what is required for an application to function, how could we kind of do that? And one of the first things that a lot of Illumio customers actually try and do is bring that network construct, or sync that deeper and deeper into the data center, applying kind of switching level ACLs, or dropping firewalls, or bringing more and dragging those firewalls closer and closer into the data center to try and attempt a mechanism of compartmentalizing and firewalling off, because that's the way that we've done it. And our perimeters are kind of based on that approach as well. But that's particularly challenging to do. It's costly as well as challenging in terms of the management and the overhead and the onerous nature of managing all of these more firewalls inside your particular data center. And of course, then what do you do when you're talking about the cloud, and how would we run firewalling in environments that we don't really control? On the flip side, a lot of organizations may have a lot of these types of technologies already. So another answer might be, well, I'm running kind of an SDN environment, so can't I just kind of automate or computerize the development of policy and utilize exactly what I've got? And maybe that will be my solution to the management overhead of those things. But again, typically what we find is that detachment of kind of the business context or the understanding at the application layer back to, say, the IP addressing of what all of these systems are based on. Kind of any sort of mismatch between IP addresses and systems and understanding causes a lot of problems in that space. A lot of the time, applications don't nicely reside on kind of these network boundaries that would make it really easy for any of these solutions to kind of carve off segments of networks that effectively. And so although they sound attractive, it generally doesn't actually end up working that well. And what we would probably like to see, though, is to kind of, if you like, separate kind of the operation of our network from the kind of the security goals that we have for the network. Because if we can maybe do that, we can get away from kind of compromising our network design to try and get security happy. And you're all the security guys, so we always want you guys to be happy as well, of course. But it's never going to work if we can't get both sides kind of playing nicely. And so, yeah, the impact that we see from this approach, and whether it's a switching approach or a firewalling approach, or whether it's trying to adopt the technology you have today in a network-centric approach, is generally that you increase the possibility that applications or the availability of those apps will fail or reduce, because you probably break something as this is all happening. And generally the worst thing from a security perspective is to break the availability of an application. No one trusts you after that, let alone the phone calls that you get all the time. Even if you are kind of operating an SDN style or an orchestrated environment, the operational overhead of managing that tends to mean that you are in a situation where the network is generally more fragile because of that nature, and the changes that you're looking to make and the reluctance to kind of change things that are working. I've seen some great environments where app team owners know exactly where they want to request their infrastructure to be placed, because that's where it worked for them last time. If it works for me there, I'll put my next app there, regardless of whether or not it shares the same kind of risk profile, because I know that I can get connectivity if I put it over there. And that's kind of, it ends up kind of either reducing the attack, increasing the attack surface, or it's certainly increasing the fragility of the environment that you have. And often, and underpinning all of this is that kind of lack of agility. And again, customers that we've talked to and a lot of people we talk to keep up with the business, we can't afford to wait 2 weeks for the next firewall burn that maybe gets fat-fingered or misunderstood and it goes wrong, and then you wait 2 weeks again for the next opportunity on a Thursday afternoon for the next firewall change to happen. Or that the request for infrastructure takes longer than you can do with a credit card in Amazon, and that just leads to shadow IT. So all of those things tend to kind of fall a little bit short. And you might be thinking, well, what on earth are we going to do then? If we're talking about a network-centric approach and the traditional approaches that we have aren't really working, how are we going to go about solving this problem? And it's I kind of think this is my second analogy. I apologize. The picture on the right isn't a Gold Coast or a Brisbane highway, because I don't think we do this anymore. But if you kind of think of it as the network teams, and the idea is that we want to have highly performing, highly connected, highly available, really fast highways and open connections, because that gives us the best opportunity from a networking perspective. But then we've got that kind of compromise or opposing thought from the security angle, which is, well, if we're going to control everything, and our way of doing that is by placing kind of network-centric controls, in this case kind of a physical control, like a physical firewall control, then we're immediately kind of compromising and traffic steering and really compromising that position. And luckily, in the road network, we kind of don't do this anymore. And I'm not really that old enough to think about it, but generally we in Australia at least, and although Sydney's getting more and more toll roads, which is not what we want, but generally we've now realized that the better way to do tolling on a highway is to actually place a transceiver in every car. And then we just simply electronically retrieve fees by recognizing when that vehicle crosses boundaries. And that's, I know that analogies you'll see, I think, coming up shortly, but taking away from a physical cache-based control on the network or on the highway and placing it as a responsibility or a transponder in each vehicle or in each server or in each workload that we are then applying that control to. Now, in this case, it's taking money from you for driving on the road, but it could equally be, or perhaps it would be a strange toll booth that would prevent you from actually reaching the road. But in our case, for security, It could be a policy that would restrict you from being able to access that particular highway or that communication flow. And if we start thinking about it that way, we're actually decoupling the control from the fabric of our network and allowing the segmentation control to sit on top of whatever topology or an environment that we would desire to have. We're no longer compromising ourselves. And to be honest, if we're thinking about a true zero trust model where everything should be kind of self-protecting, and you have to justify and assert that anything that wants to talk or act in a certain way has to justify by doing that, the only real way to do that is to kind of decouple those two things. Allow the network to be a fantastic network. Allow the security, or the segmentation in this case, to do segmentation on top of that. Get a transponder in the car onto each server and allow each server to kind of do that themselves. And I think that's the way we're going to achieve this. But it brings with it a lot of benefits. Because if we're no longer reliant on the underlying network or the infrastructure or the hardware, then suddenly all these things like public cloud start to become a whole lot easier. Because the fact that something's running in a cloud versus on-prem is no longer a factor. Because the control or the transponder is not on the network, it's in the VM, it's in the IaaS instance, it's in the OS of the compute you're running, not in the environment that's hosting that compute. So decoupling the security policy from the network infrastructure is actually going to make this possible. But saying that is really easy. How are we going to go about doing that? And what would we actually need to make that decoupling effective and achieve this compartmentalizing strategy? And these are, I think, some of the key things that are going to make this work. The first thing to make it work is that if you try and add more and more segments to your environment, more and more smaller compartments, micro perimeters, you have to be able to visualize what communication or what traffic or what the actions or the behavior of those applications are. Because if you won't, you're bound to break something. If you can't see it, you won't be able to make the right decisions about how those compartments should form. So the first thing we really want is some form of a map, if you like, that will help us guide our way through to building the right segments. But that map will also really be helpful for a lot of other reasons, because if we can finally understand everything that's going on in our extended data center, then there's a whole bunch of people in the organization that can start to talk about kind of a single view of truth. The apps teams have their context and they can visualize and understand their application behavior. The network teams can see at a network level what's going on between all those components. The infrastructure team know the servers, whether they be containers or virtual, or where they reside. They can talk the same language and work off the same diagram as well. And they can all collaborate to help build these compartments, if you like. So understanding what you have at any point in time becomes really critical to be able to achieve this. And traditionally, a network kind of visualization tool or network profiling is good at the lowest level. You can see who's top talking and what's going on, but there's no real link back to the app context. And the application kind of data flow diagrams, they're generally in Word documents in a desk somewhere that no one reads, or on SharePoint now. They don't really help you either in terms of the reality of the situation. So we need something that kind of joins those two things together and gives us a map that includes both of those things: app context, network, and infrastructure. So that's the first thing. And to be honest, that has to be live and updating. It can't be a static point in time, because all of our environments are increasingly more and more dynamic. Okay? And we need to be able to see that in a moment of time. All right, the second thing we're probably going to need, if we're going to start building segments, is we're going to have a way of grouping or labeling or logically representing the systems that are going to make up those segments. And when we talk about systems around a kind of a table or a conference table, we don't talk, well, that IP address is talking MySQL to that IP address. We use things like, well, the middleware server of application A. Now, is that the dev one or the prod one? Oh, it's the prod one. The middleware server of application A in prod is talking to the database server in application A in prod, and this one's in Munich and this one's in the Gold Coast. So when we talk about these systems, we're already kind of applying or understanding characteristics of the role, the application, the environment, where it's residing. So wouldn't it be really powerful if we started building or have the foundation of our segments reflect those same characteristics? And not only does it make it easier for us to understand them and apply them, but it also means we're no longer talking or thinking in IP addresses, which is all ephemeral and changes. And I think the last talk was all about that too. How often IP addresses change was one of the last questions that was asked. So getting away from the technical properties of a system and actually just grouping and logically naming them. So that's probably the second thing we'd need, a way of applying attributes. And those simple ones are good enough. We don't need a whole bunch of things because that just complicates the matter. But a range of those attributes that would apply to the workloads so that we can understand them. And if we keyed our segmentation strategy off them, suddenly everybody understands every rule. We're not concerned about, oh, what does that firewall rule do? Or what on earth is that thing in a list of 1,000? We can actually read these off in English that would actually make sense. And finally, the third thing that I think is really important to any of this, and to help prevent breaking things, which is the death of security in a way, is that we have to be better than our traditional security methods of being able to model and test what this policy is going to be and what it is going to do before we apply it. So we're not doing our testing of our firewalls by applying it and waiting for the phone to ring via 3 different app teams saying, you've just broken all my software, what's going on? So having some method of being able to visualize, map, write policy that's in English, and then apply that in a staged fashion that reduces the risk of breaking applications or reduces the network risk whilst not actually affecting the network at all, overlay, abstracting away, would give us that opportunity to actually build those really effective segments. And hopefully you would agree. So that's probably the 3 things that we're going to need. So let me take you through a little bit of an example. And this is where it gets a bit small, certainly for those at the back. So I'll try and talk through it as much as I possibly can. But if we think about securing something by design or through its intent or its behavior, this is perhaps how we could go about doing that, or a sequence that we might end up following. So I've got, for example, a records management application, and already I'm thinking about the name of it, and it's running in my staging environment out of a particular data center. It could be GovDC or Equinix or on my own private one, but I'm thinking about those properties already. And then in my head, I'm thinking, I know what this application is made up of. It's a classic kind of 3-tiered app of web server, middleware server, database server. And I know what the communications are between those, and someone's talking to the web front end. So I kind of got a picture of what this thing is and what it should do. And if I was going to apply that same principle of characterizing and writing a policy that would say that only the interactions for this app to work should be allowed and nothing else, no implicit allows, no trust zones, deny by default everything, 0 trust, then this is perhaps a rule set that we'd look to build. The rule set would be something like this. The scope of my application is going to be the records manager app in dev and staging running in this data center. And my rules are probably going to be something like a select group of people can talk to the web front end, and only the web front end. No one should be able to get access to the database directly. That's the first rule in English. The second rule would then be something like, well, the web tier should always go through the middleware tier because that's its vehicle, its behavior. It should never go direct to the database. So our web tier is going to talk to the middleware tier, and we know that it does that through Odoo, or hopefully the application teams are at least aware of that through Odoo. And then finally, the middleware tier is going to talk to the SQL server, in my case, MySQL server, in terms of the database. And if we could write a policy that looked like that, very different than a set of firewall rules that have to know all the IP addresses of all of those 3 machines, and we'll see in a few minutes what happens when we explode those. That's actually describing the behavior or the intent and the minimum behavior required for this application to work. Okay? So that's kind of our starting point. And as we go through this, we're going to start to see, in my case, it's a bit of a changing, evolving application. And hopefully you'll start to realize that if we were trying to do this in the traditional ways, it's going to be really challenging to maintain that same security policy. So in this case, some bright executives decided that we have a cloud-first strategy, and it's determined from on high that everything now must run in the public cloud. And so this application, this is a bit synthetic because no one's just going to pick this thing up and run it immediately in the public cloud. But we're going to take this and put this in Amazon, and in doing so, well, we will transform it a little bit as well. And we'll make use of some of the PaaS services out of Amazon to make it a little bit more better experience in that sense. But in terms of our policy, for those that can see, you'll note that the behavior of the app actually hasn't changed. The only thing that has changed is the location's no longer Equinix, Amazon Southeast, and the fact that our database is now an RDS server instead of a VM running MySQL, for example. Okay, so that's a minimal change to our policy, which could actually be applied really easy through orchestration. Okay, so that's the second one. Then, of course, this application is ready to promote into production. So we're in staging, we've done our testing, we're now going to production. What is our change to our policy? Well, the behavior of the application, again, has not changed. Now we just need to apply that same policy to the production instance, as well as applying it to our dev and test instances. So again, minimal change to the concept of our policy, but achieving that same goal of separating those applications from each other. And this is where it starts to get really cool, because if we start elastically expanding any one of those web tiers, in our traditional model, we have to start worrying about what are all the IP addresses of all these new machines in the web tier that we've just expanded out. In this model, our policy has remained the same completely, because our web tier is still talking to the middleware tier using Odoo. The behavior has not changed. So this attribute model becomes really, really key to achieving this goal and allowing that dynamic nature. And then, hey, why not? Let's go ahead and containerize this thing. And now we've got containers, we've got PaaS, we've got Amazon, and we've got this kind of classic application architecture. Again, our policy hasn't changed. Just because the web tier is now containers versus VMs, the database is no longer physical, it's PaaS, hasn't really affected the behavior and shouldn't really affect our security policy. If we do this well and tie that policy to behavior and intent, then we shouldn't have any impact on that. So how could we really kind of finish this off? Hopefully this is posing questions to you as to kind of ultimately how is this going to work. And I'd love you guys to come over to the Illumio booth and we can talk about it more. And in fact, if you're around at 3:40 this afternoon, we're doing a prize draw for a drone. So if you haven't got a ticket for that already, come over there or grab one from the guys at the back. But fundamentally, if we can decouple the security practice away from the network guys can concentrate on building the fastest, highest performing, reliable network that they want without compromising their work. The infrastructure team can be happy in the sense that they can provision any type of resource, physical VM container or whatever it might be in the future, in the appropriate place, cloud, private, regardless. They're not compromising themselves. The security group are really happy because they're achieving granular policy and much more control than they've ever had before at a speed which is so much more faster than they've ever had before. And the application teams kind of assist in this process of potentially defining their policy and operating the policy, and they're not slowed down. They're going at DevOps speed as fast as they can, and they're not, they're having a part to play in achieving that goal, and they're not slowed down by infrastructure or security as well. So it sounds like a bit of a nirvana, and I promise you, it's all very much possible, as long as we decouple our security from the network. So what are the kind of the key takeaways to this? And when you think about zero trust, it's a big framework around self-protecting systems and isolating each other and users to systems and data in systems. These are some of the practical steps that you can actually take to start achieving that goal that you've heard about, but you're maybe not necessarily at that point yet or on that journey. And the first thing is that we've got to be able to identify those systems and visualize those systems that hold that really important data. If we don't understand that, if we can't see that, if we don't have that in real time, we're not going to be able to achieve this. The second one is that we want to be able to architect these security policies that are micro perimeters and are small segments, maybe all the way down to single VMs or processes running in VMs if we want to. But be able to architect those, test them, visualize what their impact would be before we flick the switch to actually enforce them. And that's a vital part of that process. Thirdly, underpinning all of this, we've got to get away from that concept of building fences or that kind of outside-in approach of, well, we'll try and block it, and if they get through, we'll try and detect them and get them out as quick as we can. We've got to kind of flip that on its head and plan for breach and plan beyond a breach and go for a default deny model, where everyone is self-protecting and only having to justify, having to, approve a flow because that is required, as opposed to I live in a segment that is open and can be communicated in this way. And then finally, as kind of the example that I just showed you before, if we have either an application that's evolving or different teams within our enterprise that are running at different speeds with different technology trains, we've got to be able to have a way that can both automate or orchestrate this approach so that it adapts to the environment that you have And those network-centric approaches or hypervisor approaches or whatever it might be that we might have today just can't keep up with that. They just can't adapt. They're not designed to achieve that. Okay? So that's kind of my practical steps, if you like, for going through Zero Trust. And I think we're pretty much on 5 minutes to go now. And what I do want to do is make sure there's enough time for a Q&A. And hopefully there are some questions in the audience. Hopefully I've piqued your interest enough, not in telling you how to go about doing it necessarily, but it's certainly possible to achieve all of this. And so I'll open it up. And now, thank you very much for your time this afternoon, but I'll open it up for some Q&A. Thank you. Is there anybody? Yes, thank you.
One of the slides you had, I imagine you could assign attributes to applications and services.
Yeah.
Also, who component is a user like how do you
Yes.
identify that end user?
Yeah, that's a very good question. So the question was, I had a slide there that kind of identified attributes of systems in the data center, kind of very centric around the data center. But we had that concept of a company HQ or certain users accessing the front of that system. How would we do that? Well, I think in a similar way, we've got to be able to identify users using an identity framework in some way. And it's not necessarily the same set of attributes. They don't have a role in an app and an environment, but they do have a role that they play in the enterprise that would suggest that they should be able to interact with certain systems in the data center. And so, yeah, being able to apply that identity to that person and then have a policy that says, well, those types of people are allowed to access the systems. So when we think about the Illumio world, we think about that as kind of their participation in AD or a directory service. What role do they play and how would they kind of interact with the front end? But really importantly, it's not how would they interact with that whole app, it's how do they interact specifically over HTTPS only to only the web front end or whatever that might be so that you're reducing the attack surface. So yeah, the person and the system kind of, I guess, merge a little bit in terms of each one has an identity, and then you're writing policies on those identities. So hopefully that answers your question. Yeah. But we can certainly extend this concept beyond the data center into user land as well. Yeah, please, at the back. Yeah. I think certainly the concept of it as a framework is equally applicable into any type of environment. I guess there are different challenges with the different IT environments that you have. And in terms of the way Illumio thinks about this problem, how we've approached this problem, there are some types of systems that are perhaps harder to approach this from a host-based methodology because that host is maybe a black box to you or it's an appliance or something that you can't necessarily interact with that well. So yeah, there are cases where you may need to kind of think about, well, what is something that we could use that sits in front of that particular SCADA system or that OT system that could kind of front that identity or front that so we could apply policy at that point. But yeah, SCADA systems are a little bit different, and maybe you could extend that into medical devices and medical equipment, for example, as well. MRI machines that you can't play with, for example. So I think, but one of the key things that we have found in talking to a lot of customers around this is still that boundary between IT and OT is still a very important one that this is very applicable for. And then depending on kind of the makeup of your OT environment, how far you can get that down to each self-protecting system versus what might need to sit in front of it. But that's a very good question. Thank you. Yeah. Yes, sorry, yeah, one more. Use a tool? Yeah, I mean, so I tried very hard not to talk about Illumio too much, but yeah, Illumio is a software solution that provides all of these things, and one of the fundamentals is that map. And we actually have a series of those types of maps that are kind of relevant to the different person that might be interacting with the system. It's kind of a security guy versus an infrastructure type person. But yeah, fundamentally, if you need something that visualizes across the entire environment, it's got to work everywhere, and it's kind of got to work at a big scale. So yeah, we have written some technology that will do that up to hundreds of thousands of servers potentially. But yeah, it's fundamental to, I think, to be able to achieve any of this. Yeah. Alrighty, I'm kind of getting the nod, and I think we're up to time. I'd love to keep talking to you guys, but thank you.